This is all knowledge about denim, both history and development, production and purchase. And the company we are happy to support and happy to provide in technician service, including raw material in production and machinery. For those who are interested, you can contact us. We welcome you all.
During the 1950s, young America discovered blue jeans, and the industry exploded in the United States. This fashion soon spread to other cultures, and denim became more than just a piece of fabric. It grew into a social statement. Jeans have a long history, dating back to 1567 with the introduction of the root word for jeans, which is genoese or genes, which describes the tough twill trousers worn by merchant sailors from the Italian coastal city of Genoa. Serge denim was a twill cloth made of wool and silk and became popular prior to the 17th century. It was named for its city of origin, Nîmes, in France. During the 17th century, the manufacturing of this fabric spread to England and other countries and simply became known as denim. Starting in the 1700s, 100% cotton denim became the staple workwear of U.S. farm and industry workers. Today, it retains the title of America's favorite work pant. The denim jean, as we know it today, originated in 1873 when Levi Strauss and Jacob Davis patented their riveted work pant that kept the pockets and seams from bursting when doing heavy work. During the 1950s, denim went from being solely a work and utility fabric to capturing the interests of the fashion-conscious public. Companies like Levi Strauss & Company and H.D. Lee quickly responded. It's also at this time that American and European teenagers embraced denim jeans as the Elvis and James Dean look. When indigo dyes are used, it gives the denim fabric a unique ability to fade in color after repeated laundering. Indigo dye originated as a vegetable dye from the Indigofera tinctoria plant in India and Africa thousands of years ago. An indigo-dyed robe was found during an excavation in Egypt and is estimated to have been made around 2500 BC. In the Americas during the same time, a different type of indigo plant, Indigofera saffractiosa or Indigofera erecta, were used to make Natal indigo dyes. It was an important dye for the Mayan people who used it to paint their sacrifices prior to scarification, as well as dyeing the royals' clothing. In the cooler climates of the world, like Europe, indigo was also produced from the Isatis tinctoria or woad plant, and Polygonum tinctorum, also known as dyer's knotweed. In 1878, German chemist Adolf von Baeyer invented the first synthetic indigo dye. In fact, indigo was the first synthetic dyestuff. By 1914, almost 95% of the natural indigo trade had disappeared. Today, synthetic indigo dyestuff accounts for essentially 100% of all denim products. During the 1980s, there was a designer jean craze with many styling variants. This phase ended in the 1990s when Levi Strauss & Company created the Back to Basics slogan. This began the revival of the ring-spun denim. But by the mid-90s, the designer jean craze had resurfaced with many companies producing their own brands. Today, advances in finishing techniques, especially garment processes and fabric technology, have created a high-tech denim jeans market. With the warp yarns dyed using blue indigo dye and the filling yarns being left undyed. Also, there are a number of alternatives for denim dyeing that are routinely used to obtain specific fabric appearance or performance. With the advent of denim garment washing techniques, the construction and dyeing techniques used are of utmost importance. The selection of yarn, the consistencies of the indigo dyeing process, and its modifications have become crucially important in determining the quality and performance of indigo denim products. The properties of the indigo dye account for the wide variety of color designs that are available on denim products. Indigo is unique as a major textile dye because the indigo dyeing process naturally ring dyes the cotton yarns. Unlike almost all other commercially successful dyestuffs, The indigo dye concentrates in the outer layers of the yarn during the dyeing process. This produces an intense ring of color around a white core in the yarn, thus the name ring dyeing. With most dyes, if ring dyeing occurs, it's considered a dyeing defect. Also, indigo dye, an intense blue, is insoluble in water and will not dye cotton fiber. In order to dye cotton yarn, the indigo must first be converted into a water-soluble leucoform and then applied. This chemical process is known as a reduction. Reducing solutions containing sodium hydrosulfite and sodium hydroxide chemically change the indigo dye into its soluble form. This process also converts the dye from its intense blue color to a very pale greenish-yellow color. The outer layers of the yarn readily absorb this leucoform of indigo. Once in the yarn, the indigo is returned to the insoluble form by oxidation. During oxidation, the ropes of yarn pass through the air in a process called skying. The oxygen in the air converts the dye back to its original insoluble form, and its blue color returns. In traditional rope or ball warp dyeing, the following steps are involved: scouring, indigo dye application, rinsing, and drying. The ropes are first fed into one or more scouring baths, which consist of wetting agents and detergents. The purpose of these baths is to remove naturally occurring impurities found on the cotton fiber, such as dirt, minerals, ash, and pectin. Additionally, the waxy layer on the fiber, which repels water, is also removed. It's very important to remove these materials to guarantee uniform wetting and dyeing. The ropes are subsequently fed into 2 or more water rinsing baths. The key to this process is the dyeing segment, where the indigo dye is added in layers to the outer surfaces of the yarn. In rope or ball warp dyeing, the yarn is passed into a vat of soluble indigo dye that exhausts on the surface of the yarn and is then oxidized. This results in a small amount of dye being deposited on the surface, yielding only a light blue dyed yarn. In order to obtain a deeper blue indigo shade, the dye must be built in layers by multiple passes of the rope of yarn into the subsequent vats of soluble dye and then into the air for oxidation. Each of these cycles is called a dip. Normally, this process is repeated from 3 to 9 dips in order to build up a rich, deep blue color. If even darker shades are desired, a sulfur black or sulfur navy dye can be applied to the yarn prior to the indigo dyeing. This is known as a sulfur bottom. If the sulfur dye is applied after the indigo, it's known as a sulfur top. When a sulfur bottom is required, the scoured ropes of yarn are then fed into a bath of a reduced sulfur black dye. Similar to indigo, sulfur dyes are water insoluble. They must be reduced to a water-soluble form prior to application. Unlike indigo, the sulfur dye can penetrate into the core of the cotton fiber, thus darkening the overall color shade. Once the reduced sulfur dye is applied to the ropes of yarn, the dye is allowed to oxidize to its normal water-insoluble form. The ropes are then fed into 1 or more water rinse baths. These baths remove any unfixed sulfur dye that might contaminate the indigo dyeing process. Then the normal indigo dyeing process begins. In rope dyeing, ball warps are continuously fed into the rope or chain dyeing range for application of the indigo dye. Typically, 12 to 36 individual ropes of yarn are simultaneously fed side by side into the range. The ropes are kept separate from each other throughout the various parts of the dye range. Each rope of yarn typically contains 250 to 400 individual cotton yarns. The actual number of ends in each ball is determined by the number of ends that are required on each section beam. For example, if we have 30 ropes on a dye range, and each rope has 350 ends, then the dye range will be producing a dye set with 10,500 ends. The dyed yarns from each rope are separated onto a section beam. In this dye set, there would be a total of 30 section beams. In most cases, this would mean that this dye set could be broken down into 2 subsets of 15 section beams, with each containing 5,250 ends. The ropes of yarn are then fed into the reduced indigo dye baths. Once reduced, the indigo dye takes on a pale greenish-yellow shade. The yards are then skied as much as 30 to 40 feet into the air to allow the oxygen in the air to convert the indigo back to its normal water-insoluble blue shade. As the yarns oxidize, they change from a light greenish-yellow shade through various darkening shades of blue-green until they become the deep blue indigo shade. Denim shades require as few as 3 or as many as 9 dips and skying processes. The ropes are then rinsed in several water baths to remove any unfixed or surface dye deposits. Another option would be to add a sulfur top after the indigo dye has been applied. The sulfur dye still migrates toward the core of the fiber, but the sulfur top produces a different type of color performance, especially in garment washing procedures. The sulfur top process is followed by 1 or more water rinses to remove any unfixed dye. After rinsing, the yarn ropes pass through squeeze rolls to mechanically extract water. The yarns are then dried and coiled into large tubs. The typical drying apparatus is multiple stacks of drying cans. These metal cylinders are filled with pressurized steam. Care must be taken not to over-dry the yarn, or the dye will excessively migrate to the surface of the yarn, increasing the tendency of the color to crock. Additionally, if the surface of the drying can is too hot, the yarn can be overstressed, producing an undesirable shiny or ironed appearance. Coiling takes place after drying. The ropes exit the drying cans and are lifted high into the air and then coiled into large trucks or tubs. Each individual rope is placed into a separate truck. After drying, the color of the yarn is checked either visually or instrumentally. With many indigo dye ranges, the color of the yarn is continuously monitored by a color spectrophotometer, which is electronically linked to the controls of the indigo dye baths. This type of control system can automatically adjust the dynamics of the process to obtain the most consistent color from the beginning to the end of the many thousands of yards of yarn contained within a single dye lot. In order to minimize the color variability often seen between denim panels after garment washing, denim manufacturers will try to use the same dye set or lot to fill a customer's order. Each roll is sampled, and a piece of fabric from each is sewn together into a patchwork blanket and garment washed using the customer's garment washing recipe. The swatches are then shade sorted using a color computer, and if they fall within the guidelines of the customer, the cloth is shipped to the customer. Once the warp yarns are rope dyed, it's then necessary to change the yarn alignment from rope form to sheet form prior to entering the next process, which is slashing or sizing. Beaming or rebeaming involves pulling the dyed ropes of yarn out of storage tubs and moving them upward to a guiding device, sometimes called a satellite. This upward travel allows the ropes to untangle before reaching the beamer head. Once the ropes come down from the guiding device, they go through tensioning rollers to help further separate the yarns prior to going through a comb at the warper. The comb separates individual yarn ends and keeps them parallel to one another. From the comb, the warp yarns are guided onto a flanged section beam. Depending on the length of each rope, multiple section beams can be made, forming a set of beams. These beams are grouped by dye set, as well as what section of the dye set they were dyed. For example, a 30,000-yard dye set, we'll call dye set 100, may be broken down into 3 sets of 10,000-yard beams. The first 10,000 yards would be dye set 100A from the top of the rope tub. The second 10,000 yards would be dye set 100B from the middle of the rope tub, and the last 10,000 yards would be set 100C from the bottom of the rope tub. The mill would then slash and weave all beams from set 100A together, set 100B together, and set 100C together. Each set will normally contain 8 to 14 section beams. The total number of yarns on all the beams should be equal to the total number of ends in the fabric. For some producers, sheet or slasher dyeing of indigo has become a reasonable alternative method. Slasher ranges are normally only used to apply size onto the warp yarns prior to weaving, however. They can be adapted to fit onto the exit end of a sheet dyeing range to make dyeing and slashing a one-step process. A sheet dyeing slasher range used for indigo dyeing consists of a creel of section beams for the warp yarn. This yarn is sheet-fed into a scouring section where the natural impurities are removed. After the impurities are removed, the indigo dye is applied. Just like indigo rope dyeing, in order to achieve fairly deep shades, the indigo is applied in a series of multiple dip and sky applications to allow for the buildup of shade. If the arrangement of the sheet dyeing range does not allow for multiple dip and sky cycles, then only light and medium shades can be obtained from indigo dyes. The dye application is followed by afterwashing, and the yarns can either be thoroughly dried or left with some moisture in the yarns before they enter an accumulator. The accumulator ensures that the dye range does not have to stop while the slasher has a loom beam doffed or a new beam started. In the slasher section, a normal sizing operation occurs where a weaving size is applied to protect the yarn. Slasher or sheet dyeing ranges have a number of advantages and unique characteristics. Sheet dyeing uses section beams instead of ball warps to form a sheet of yarns, which are wound directly onto loom beams. As discussed in rope dyeing, additional handling of the yarn is required. Slasher dyeing works well when manufacturing lightweight denims. In general, slasher ranges require minimal floor space, enable smaller production runs to be more profitable, have rapid turnover time, and are highly flexible in their response to changes in the market. Additionally, the slasher dyeing technique can be used for other types of dyes for cotton, thereby producing a wide variety of colors other than indigo blue. Another dyeing technique that has been used for dyeing warp yarn for denim is beam dyeing. In this technique, hundreds of individual yarns are wound parallel to each other around a perforated flanged beam. The beam is then loaded into a cylindrical dye vessel that is sealed, so that dye liquor can be pumped through the perforations in the beam and then through the yarn. After dyeing, the yarn is afterwashed, extracted, dried, and then added to other beams to form a full set for slashing and then weaving. This technique does not lend itself to the unique dyeing properties of indigo. Therefore, it's normally used with other dye types, including reactives, directs, sulfurs, and vats, resulting in a wide range of colors. This is also a well-known and accepted technique for many different constructions of cloth other than denim. It's possible for denim fabrics to be finished and sold without going through any dyeing process. These fabrics are known as natural denims and sometimes are called bull denims. These natural state denim fabrics exhibit the off-white cream color of natural cotton. After finishing, cutting, and sewing into garments, natural denims can be used like traditional denim garments, or they can go through garment dyeing and other wet processing to yield various properties. These garments will not show the color contrast effects shown by traditional denim garment processing because both warp and filling yarns will be dyed. These natural denims can also be bleached to yield market or finished white denim products. Continuous dyeing techniques are also used to dye natural denim fabrics into solid shades. This method is not normally used for indigo, but is commonly used for sulfur, vat, or reactive dyes. After dyeing, these denim fabrics can be finished using the typical denim finishing sequence.
This is all knowledge about denim, both history and development, production and purchase. And the company we are happy to support and happy to provide in technician service, including raw material in production and machinery. For those who are interested, you can contact us. We welcome you all.